And let's get to it. Okay, I am on page 292. Section 7.1 is a rather gentle dipping into the next chapter. So let's get to it. First of all, I'm confident that everybody understands the concept of square root. For instance, 25. 25 has a square root of 5. But 25 also has a square root of negative. What is that on my back? Pardon me, folks. Chickens, rubber chickens seem to be rampant around here. I think it must be a chicken pandemic. All right, where were we? Sorry. 25 has a square root of 5, but it also has a square root of negative 5. Why is that? Because what does it mean to take a square root? What number, when multiplied by itself, gives 25? Well, negative 5 works, 5 also works, because 5 squared is 25. Negative 5 squared is also 25. They both work. So 25 has two square roots. But now I guess you would say, to simplify things, consider this. This symbol, it's called a radical sign. I'm sure you've heard that before. The radical sign is going to be used to indicate the principal square root. It is called the principal square root. The principal square root is the positive square root. So when we use this symbol, the square root of 25 is only 5. It is not 5 or negative 5, it is simply 5. So if you see the words square root of 25, there are two answers. They are 5 and negative 5, which is more commonly written as plus or minus 5. But if you see this symbol, that symbol represents only the principal square root, so the answer to this one is strictly 5, not negative 5. If you want the negative square root, because yes, there is a negative square root of 25. If you want the negative square root, you have to ask for it. How do you do that? You put a negative sign in front of it. That is negative 5. Now, things to remember here. Consider consider the square root of negative 25. Now, beginners will look at that and say, oh, it's obviously negative 5, isn't it? Well, think about it for a second. Is negative 5 squared equal to negative 25? No. Negative 5 times negative 5 is positive 25. Oh, I see. So it has to be positive 5. No, 5 squared, no, that doesn't work. What works? Nothing works. In the real number system, which is what we're currently operating under, but not forever, in the real number system, there is no square root of a negative, because nothing, when multiplied by itself, can ever give a negative answer. So in the real number system, this does not exist. There's no such thing as the square root of a negative. How about square root of 0? Well, does it exist? Is there a number which, when multiplied by itself, gives an answer of 0? Yes. Square root of 0 is 0. Why? Because 0 squared is 0. You're going to see some problems like this. Let's see if I can find an example in the book here real quickly. Some problems in the book where they're going to give you something like, where is it? I'll find it in a moment here. Oh, I'll just make one up. Is it time for that? Okay, yeah. They might give you something like this. Square root of x equals a. And ask you to put that into exponential form. What does this mean? Well, what does the square root of 25 equals 5 mean? It means 5 squared is 25. So what does this mean? It means a squared equals x. So your answer here would be a squared equals x. If they ask you to put this into exponential form, it means to write a squared equals x. More on that later. Now, they give some examples. Page 292, example 1. They ask for the 2 square roots of 64. Or they don't even have to put in the word 2. They could simply say in words, find the square roots of 64. Find the square roots, notice the S there, of 64. In words, your answer would be positive 8, negative 8, otherwise known as plus or minus 8. But if they ask for this, then your answer is what? Yeah, 8 and only 8, because this is asking for the principal square root, the positive square root only. All right. Oh, by the way, I'm looking at the try this problems on page 292. It says try this. Nice thing about the try this problems is all of the try this answers are in the back of the book. So you can review in the book, find some of the try this problems, check them out, make sure you can do them, check your answers in the back, and that will help tremendously. Make use of the try this exercises in the chapter, in the sections. Now, don't let fractions scare you. What's the square root of, say, 4 25ths? Well, isn't 2 fifths times 2 fifths equal to 4 25ths? Yes. So the square root of 4 25ths is just 2 fifths. So don't let those scare you. Fractions are not always scary. In this case, fractions are no problem at all. It's kind of like 2 little square root problems built into one. Here's another one that tends to be a little bit scary looking. How about square root of 0.0049? Square root of 0.0049. Well, hopefully you remember something about how decimals work with multiplication. This turns out to be 0.07. Why is that? Because what's 0.07 times 0.07? Do you remember your basic arithmetic? 7 times 7 is 49, and we're done. But we have 1, 2, 3, 4 decimal places. So we must have 1, 2, 3, 4 decimal places here as well. So 0.07 works. It works. So your result is 0.07. Mr. Pierre, why do you count decimal places? Oh, well, because we're multiplying hundredths. We're multiplying hundredths. Actually, we're multiplying 7 hundredths by 7 hundredths. Right? That's what 0.07 means, 7 over 100. And when you multiply 7 hundredths times 7 hundredths, don't you multiply the denominators? Yes. 100 times 100 is 10,000. So we get 49 10,000ths. And if this has 2 zeros and that has 2 zeros, you know this will have 4. That's why your answer has to have 4 decimal places, because it becomes 10,000ths. Because that's what happens when you multiply hundredths by hundredths. You get 10,000ths. It makes sense. We move on now. I'm looking over here at page 293. And on 293, we have a complication. A little complication that's going to be very annoying, but I'm sorry, we have to deal with it. Here's the complication. What if we have the square root of a squared? What would you multiply by itself to get a squared? One would say, well, How about just A? Okay, yes, sort of, but not always. What do you mean not always? Well, let's consider this. Suppose for a moment, we're going to check to see if this is true. We're going to see if this is true by plugging in some numbers. Suppose A is, 6. Suppose A is 6. Does this work? If A is 6, we would have, let's get this out of here, put it over here. If A is 6, we would have the square root of 6 squared. Is that equal to just plain 6? If I change the A and the A into a 6 and a 6, is this statement true? Well, this gives me the square root of 6 squared, which is the square root of 36, and the square root of 36 is correct, so this works. But here's the problem. What if, let's change it. What if A happens to be not 6, but suppose A happens to be negative 6. Suppose A is negative 6. Suppose A is negative 6. Is this statement still true? Well, what's negative 6 squared? Of course, positive 36. Is the square root of 36 equal to negative 6? If this means the principal square root, if this means the positive square root, is the positive square root of 36 equal to negative 6? Well, no, that's silly. It's not true. So this statement is not always true. But what if we cheat the system a little bit here? What if we say, not that the square root of A squared is A, but suppose we say that the square root of A squared is the absolute value of A. Would that work? Let's try it. That means I change the A to a negative 6 here. I change this A to a negative 6, but I take the absolute value. Now what happens? What is the absolute value of negative 6? I'm sure you remember how that works. Absolute value of negative 6 is 6. Is the square root of 36 equal to 6? Yes. Now it works. Now it works. So here's the bottom line. Do you have to remember all of that explanation? No. I will occasionally remind you of why this is true. The important thing is for you to know that that is the truth. Square root of A squared is not equal to A all the time. Square root of A squared is always equal to the absolute value of A. Guaranteed. So that means, let's look at some examples of how this nasty little creature works. Suppose I have, example 5 is a pretty straightforward example. I don't think you would need to know this in order to survive example 6. You don't need this to survive example 6. Example 6 says this, and squared. Okay, you also don't have to multiply 16 by 16, because we know that the square root of A squared is the absolute value of A. So that means that the square root of negative 16 squared must be the absolute value of my A value, which this time is negative 16, which is 16. Or if you want to go to the trouble, you could say, well, what is the negative 16 squared? Negative 16 times negative 16 is positive, get out the calculator, positive 256. And what's positive 256? Get out the calculator again, find the square root of 256. Oh, it's 16. So, it works. It's 16. Yes. So, we always, when doing the square root of something that's squared, your answer will always be the absolute value of this guy, whatever that guy is. Let's take a look at example 7, which is a little bit trickier. the square root of 3b squared. Well, that's not tricky. Sure, it is actually kind of tricky. Because here's the deal. According to the rule we just saw, it's not equal to, think about, by the way, I didn't mention this. The square root sign, the radical sign, the square root sign cancels out the square. A square and a square root undo each other, don't they? For instance, square root of, say, 3 squared. 3 squared is 9. What's the square root of 9? Is it not 3? So a square root and a square cancel each other out. We're left with just 3. Well, that's what we said a moment ago, that the square root of a squared is simply a, but not really, it's the absolute value of a. Yeah, not really, it's the absolute value of 3, which is 3. So over here, this must be simply 3b. Ah, but wait a minute, no, it must be the absolute value of 3b. Now here's the trick on this. This little step I'm about to show you is actually done in the head. This can be split into absolute value of 3 times absolute value of b. But we know the absolute value of 3. That's just plain 3. We don't know the absolute value of b because that depends on what b is. If b happens to be positive, then it's just b. But what if b is already negative? Then the absolute value of a negative number is going to be positive. So we don't know what the absolute value of b is. It depends on what b is. So we have to keep the absolute value sign. And this is not considered simplified. Not yet simplified. It's not simplified until you've taken out everything that we know the absolute value of. And I know the absolute value of 3, so it comes out. It's very similar to the old concept of pa-ching, which I don't think we've done in one of our videos yet. We'll get to that later. So the 3 comes out. We're left with the b inside because we don't know what the absolute value of b is. It might be b, or it might be the opposite of b, depending on whether b is positive or negative to start with. Oh, I know this is kind of tricky. Here's another weird example. How about square root of x minus 1 squared? Well, again, the square root and the square cancel each other out, so we have just x minus 1. But wait just a moment. Anytime you take a square root of something with a variable in it, you need the absolute value. It'll be not just plain x minus 1, but it's going to be the absolute value of x minus 1. That's vitally important. When it comes time for the Chapter 7 test, you will be held accountable for that little detail. Oh, here's a fun example. I like this one. How about x squared plus 8x plus 16? Now, in the videos, we've not reviewed how to factor this yet, I don't believe. But you may remember the RAP test. Well, I know you remember the RAP test. The RAP test. Yeah, we get that rhythm going, you know? I've never actually been recorded doing this as far as I know. Here we go. The RAP test says, what was squared, multiply and double. What was squared, multiply and double. What was squared, multiply and double. What was squared? What was squared? Multiply those two and double your answer. Does it match the middle term? Yes, it passes the RAP test. What was squared, multiply and double. Does it match the middle term? Yes. So it passes the RAP test. If it passes the RAP test, what's that mean? What's the point of passing the RAP test? If it passes what was squared, multiply and double, that means that we really have here the square root of x, what was squared, plus, and what was squared here? 4, quantity squared. The RAP test helps you to factor a perfect trinomial square. If it doesn't pass the RAP test, then it's not a perfect square, and you can't do this. So now, what do we have? Similar to the previous example. The square root and the square cancel each other out. We're left with x plus 4, right? Wrong! Good, you got it. It's not x plus 4. It's the absolute value of x plus 4. Mr. Parent, yes? Can we take out that 4? No. If it were 4 times x, yes, we would take out the 4 and be left with the x. But this is not multiplication, it is addition. Long story short, no. You leave it just like that. Absolute value of x plus 4. Don't even think about trying to take that 4 out. I mean, if you're thinking about it, stop right now. Don't think about that pink elephant. Okay. Now, there's some try this problems at the bottom of 293. I highly recommend you give it a shot. And watching the clock here, my phone cuts me off after 30 minutes, so I've got about 8 minutes left. Oh no, I would really like to finish. There are other roots than just square roots. We know, for instance, that 2 to the third power is, and please don't make the mistake of telling me that 2 to the third power is 6. This does not mean 2 times 3. Does this mean 4 times 2? No, it means 4 times 4. So what does this mean? It means 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. 2 times 2 times 2 is 8, not 6. Don't make that elementary mistake. So, to reverse this, to put it in radical form, here's how we write it. It's not the square root of 8 we're taking the cubed root of 8. We put a 3 in here. This is called the index. The index is 3. By the way, this number is called the radicand, and this is the radical sign. The radical sign, the radicand, and this guy is the index. So what's the cubed root of 8? It's asking the question, what do I multiply by itself 3 times to get 8? That would be 2. Why? Because 2 to the third power is 8. Because 2 to the third power is 8. So the cubed root, we call it, or cube root of 8 is 2. Now what's the cubed root of negative 8? Does it exist? Can you take the cubed root? We cannot take the square root of a negative. But can we take the cubed root of a negative? Well, wouldn't it just be negative 2? Yes. Because what's negative 2 times negative 2 times negative 2? Oh yeah, it's negative 8. Right, it's negative 8. So it does work. Cubed, you can do the cubed root of a negative. And it will always be negative. Now that has another implication. We know that the square root of a squared is not a, but it's the absolute value of a. What about the cubed root of a cubed? What's that? It's always simply going to be a. No absolute value. In fact, if you put the absolute value around this, you just killed it. You are wrong. Because if a happens to be negative, the cubed root of a negative cubed is still going to be negative. You can't take the absolute value. You've got to keep it the way it is. So, and by the way, here, there is an invisible index. Here the index is 3. Here the invisible index is 2. If there's no index shown, it's understood to be a square root. If your index is even, then you need the absolute value. If your index is odd, never use absolute value. Don't dare. So that gives us things like, looking at example 11, cubed root of negative 27 would be negative 3, because negative 3 to the third power is negative 27. Okay, what else do we have here? And one more example, skipping over to example 13. Example 13, the cubed root of negative 8 y to the third would be, well, what's the cubed root of negative 8? Oh, it's negative 32. Good. And what's the cubed root of y cubed? The cubed root and the exponent of 3 cancel. We get negative 2y. No absolute value. Why not? Because it's an odd index. No absolute value. Yes, we can do 4th roots and 6th roots and stuff like that. For instance, the 4th root of x to the 4th is absolute value of x. What's the 5th root of x to the 5th? Just plain x. No absolute value when you have an odd index. And we move on to, see, I think I've covered all that quite adequately. Find the following. What does that mean? I don't even understand what the actual question is here. Oh, they're giving you the answer right in the question. Okay, yeah, 21. It says to find the 4th root of 16. 4th root of 16 is not 2. This is not asking for 4 squared equals 16. No, the 4th root of 16 is 2. Why? Because 2 to the 4th power is 16. Because 2 to the 4th power is 16. Because 2 times 2 times 2 times 2 is 16. So be careful. Watch out for knee-jerk reactions, which will often mislead you. All right, I think that's, oh, and once again, what's the 4th root of negative 16? There is no such thing. You can't take an even root of a negative number. But you can take an odd root of a negative number. This would be negative 2. Because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is negative 32. It works. Okay, I feel like I kind of rushed through the end of that, but I wanted to squeeze it in before my phone cuts me off. So, last detail here is the assignment. And I highly recommend you try some of the try this problems. Answers are all in the back of the book. Your assignment is on page 295, numbers 2 through 42 even, 2 through 42 even, and it's due by noon on, no, let's make it noon on Friday. It's due by noon on Friday. All right, that's it. And I hope you have a marvelous rest of your day. And I hope having this due on Friday will give you a little bit of a breather. And that's that. See you later.